We are on page 19, and we are focusing today on finding the distance between 2 points. So the distance formula. What is the distance formula? Okay. Apparently. Okay. We want to know how far is a coordinate from a second coordinate. Ms. Hillman, why are there little ones and twos? Okay. Those are just to say, hey, this represents coordinate number 1. This represents coordinate number 2. Okay. And I'm going to have you write down the formula. You're not going to panic because A, I'm going to show you how to use it. And B, you don't have to memorize it. I will give it to you. So our distance formula, D for distance, okay, we are going to figure out how far apart are the x's, square it. How far apart are the y's, square it, and it's under a square root. As we went through in that little blue warm-up book thing, the Pythagorean theorem is what we're doing, but in the coordinate plane. What? You know what? I am going to set you up for success. Okay? So first of all, if we have a picture, and I'm asking, hey, what's the distance between these 2 points? I'm asking you for how long is this segment? Guess what we can do? What can we do? Okay, we can draw a right triangle. So I'm going to draw either up or down until I get to where I can go over. Do you see how I did that? You're going to draw up or down and then straight across. Because you know what we can do? We can count boxes if we're vertical or horizontal. Right? We can count 1, 2, 3, 4, 5, 6. It looks like this side is length 7. Do you agree? Okay, count the bottom. How long is the bottom? I haven't heard a number. 6. Let's count. 1, 2, 3, 4, 5, 6. Okay. So now, if I want to find C, the hypotenuse, this is a right triangle, correct? Yeah. Okay. 7 squared plus 6 squared equals C squared. Oh, we can do the rest, can't we? 7 squared is 49. 6 squared is 36. Okay, big brains. You need to add 49 and 36. Yes, it is 80. Yes, it's 85. Yes, it's 85. Nope, 85. Okay, so now what do I need to do? Or am I done? Okay, to get rid of the square, we need a square root. So that C is the square root of 85. Okay. So what I need you to do, I need you to go down to number 3. I want you to draw the triangle for number 3. Straight up and down, straight left and right. Is this going to be a large or a small triangle that you draw?
Small.
Small. Okay, draw the triangle. How far are you going to go up or down? Okay. It looks like all I need to do is go down 1 and over how many? 2. Okay, so use the Pythagorean theorem to find me C. Do you need to stand up?
No, it's not taller.
So I disagree with 4 and 2. Didn't we say that this is 1 and 2? I don't either.
Oh, from that number.
So basically, like, I started here. So I started here and I went down until I was like, oh, there's the dot. So now I need to go straight over. Because that's, yep. And then when I go straight over, I get there. Okay. A squared plus B squared equals C squared. What do you get for C? I would not say 5. Square root of 5. Okay, square root of 5. Okay. Now, in number 4, why is it doing that? Oh, what's true about number 4? The 2 points are what? They're vertical, right? If you have vertical or horizontal, do I need to make a triangle to figure out how far apart these are? Okay, let's count. 1, 2, 3, 4, 5. This is a vertical line, 6 units long. That's your answer.
Oh, just 6 was?
Yeah. If it's straight up and down, vertical, or straight side to side, horizontal, you don't need to make a triangle. I know. Okay. Now, Miss Homan, you had me write down this formula. We haven't used it yet. You're right. Okay. If we have a picture, it just makes sense to use the Pythagorean theorem. Okay? But if we don't have a picture, like here at number 6, we're going to need to use the distance formula. So could you do me a favor? And could you write x1, y1 and x2, y2 above those 2 coordinates? Okay, so I know some of you are a little worried about the formula, so this is what I have for you, okay? What I'd like you to do is I would like you to take this blue sheet that I just gave you, and can you please write the coordinates R and S from number 6 right here. So R is -2, 3, and S is 3, 15. Okay. If you can read letters and numbers, it's not even words. If you can read letters and numbers, oh, did I give you too many? Then you can place the numbers where they go in the formula, And then all we have to do is do the math. Okay? Thank you. So, here is the distance formula. Notice this is what I had you write down on page 19, right? Okay. This is x2. Which one is x2? Okay. So right here, I'm going to write the number 3. Okay. Now, I need x1. Where's x1? Okay, here's x1. I'm putting it here, -2. Okay, now in the next box, I need y2. Where's that number? 15. So I'm going to put 15 right here. Then we have y1. y1 is from the first coordinate. That's why I call it y1, and it's 3. Okay. Okay, so what I've done is I've taken our coordinates and I've put them in the correct boxes. Now we do math. What is 3 minus -2?
5.
I heard 1 and I heard 5. One of them is right, one of them is wrong. Subtracting means adding the opposite.
Told you.
If we add the opposite, it is 5. Okay. What is 15 minus 3? It's 12. Okay. All right, now what is it telling us to do? Now we have each of these numbers. Now this looks like a Pythagorean theorem problem, right? I have 5 squared plus 12 squared. What is 5 squared? 25. And what is 12 squared? 144. Okay, so now we need to add these two numbers together. Okay. Now, just like we did yesterday, we need to decide, is this an irrational number or can I rewrite it to be rational? Okay, what number is it? You said it's rational. What is it? Is 169 a perfect square? Yes. Okay, Germany. It is 13 squared, so our answer is 13. Okay. Okay. Now, I understand that you might think that this is a waste of time, but I want you to come to page 19, and I would like you to copy down everything that we just wrote down in the boxes. So it's just a few steps. So you can go off of your blue sheet. You can go off of mine up here. But I just want something like that. Okay. So you are writing this down on page 19 so you have it to look at. Some of you are going to love the blue sheet. You're like, this is awesome. I'm going to use it for every problem. There are, what? 3 on the front, 4 on the back. There's more spaces for you to be able to do more problems. We're going to do another problem in class, and you're going to have some homework. Anytime you have a distance formula problem, whether it be in class or on the test, I will have either an entire sheet or just one of those little rectangles for you. Okay? You will always have access to this step by step. Some of you might think, that's ridiculous. I can do it like this on my paper without it. You decide what works for you. So I want you to make that decision right now. And we are going to do, we're going to do number 8. Okay, so you decide, I'm doing this on the blue sheet or I'm doing this just in my notes. If you're doing it on the blue sheet, okay, we're doing number 8, right? And we have coordinate E is negative 12, comma 2, and coordinate F is negative 9, comma 6. Okay, now all we gotta do is fill in boxes. Which one is x2? Negative 9 minus, which one is x1? Negative 12. Okay, then we need y2. Which one is y2? 6. Which one is y1? Okay. From here, integer operations. This is why we spent so long on this. Negative 9 minus negative 12. Okay. Subtracting means adding the opposite, so this is a 3. What's 6 minus 2? What's 6 minus 2? Okay. Now, whether this is a 3 or a negative 3, when you square a negative number, it's going to become positive. Now, I have a positive 3. I'm just saying, if it's a negative 3, it wouldn't matter because it's still going to be a positive 9. 4 squared, 16. Ooh, so we have the square root of 25, which we can write as 5. Sometimes we're going to get rational numbers. Sometimes we're going to have to leave them irrational under the square root. Okay? Okay. So this is what you're going to do. You're going to turn to page 20, please. Okay. On page 20, you need to use the distance formula for 1 through 4. Now, no. You can use the blue sheet or you can write your work on page 20. I don't care. What do you think I would like you to do for numbers 5 through 8? Make a triangle and do the Pythagorean theorem. Okay? What I'm going to do for you is